Welcome to another math session at Panther Math Corner. And this is Dr. Howard, your teacher for NC Math 1. This is another maths course video to help students solving inequalities. And this session involves multiplication division properties of inequality where C is greater than 0. And what you see right now are 4 set of rules for inequalities when multiplying and dividing inequalities, multiplication and division operations. And I will show you some examples and tell you the meaning of C greater than 0 through the examples. So let's get started with the first one. And as you see the rules before you, it applies for if A is greater than B and C is greater than 0, then you multiply C on both sides. If A is greater than B and C is greater than 0, then you divide by C on both sides. So what you do on one side of the equation, you do it on the other side. This is where the balance is. Now I'll show you the example, and it applies for less than with the operations for multiplication and operations for division, as well as your less than equal and your greater than equal. It applies the same way. All right, here's the first example. What we're going to do is we're going to solve the inequality and graph it as well. Solve x over 8, which is greater than negative 5. All right, x is x over 8, or 1/8 x greater than negative 5. First thing you do when you have a type of fraction for your variable, where your variable is in the numerator and the number is in the denominator, you multiply by the number in the denominator on both sides of the inequality. And an easy hint for this is that whenever you see this type of form where you have a fraction for the equation part, and in this case a fraction part where the denominator is the variable and the numerator with the denominator, the denominator is the number and the numerator is a variable, you multiply by a whole number, which is the whole number for the denominator. So you're going to multiply 8 on both sides. Greater than negative 5, 8. The 8 right here represents your C. All right. So if C is greater than 0, then you can multiply the value in which you multiply on both sides. And that fits the equation when you balance the equation. What you do on one side, you do on the other side. And it also applies for the inequalities. So this cancels. You have x, which is greater than negative 5 times 8, which is negative 40. All right. Now, all the numbers that are greater than negative 40, all right, I'm going to do it like this. So all the numbers that are greater than negative 40, if we go this way and in this direction, negative, you have a negative 40, negative 41. All the numbers are smaller. They're going smaller when you go this way, so it can't be this way. So it's going to be an open circle, and then it's going to go to the right. All the numbers are greater than negative 40. Negative 39 is greater than negative 40. And then 0 is greater than negative 40. So it's in the right direction. Okay? All right. Okay, this is the example of when you multiply using multiplication on both sides. Let's do another one where we can divide. All right, we can divide. Excuse me for the noise. When we can divide, when I was shifting the information, when I was shifting my little bottle, I make some noise. Okay, all right, we have a negative 24 which is greater than equal to what? A 3x. All right. Okay, this time we have a whole number next to the variable. In the last example, we had the variable in the numerator and the number in the we had the variable in the numerator and we had the number in the denominator, and we had to multiply by a quantity of the denominator on both sides. Now in this one, we're going to divide on both sides, so it fits the next multiplication, the division rule, which is if A is greater than B, okay, and if C is greater than 0, then we divide on both sides by C. And we're going to do this right now. So I'm going to write negative 24 just to illustrate it one more time of dividing. So we're going to divide 3 on both sides. Right here, this is your C value. All right, the repeated C value that applies to these these properties of inequality rules where C is greater than 0, this is your C value. So you do it on both sides of the inequality. All right, so negative 24 divided by 3 will give you negative 8. And then 3 over 3 will give you 1. It cancels. So you have 8 greater than equals to x. Negative 8 is greater than equal to x. So let's graph. Excuse me. I'm going to put negative 8 here and then positive 8. I'm just doing the cheating instead of writing all of the units all at once. All right, so negative 8 is greater than x. That means that all the values of x are smaller than negative 8. That means a negative 8 is greater than equal to x. So this is going to be a closed circle, shaded, because it's greater than equal. And what values when 8 is greater than x? We can see here if we go this way, negative 8 is not greater than 0. So that's in the wrong direction. So it has to be this direction. And let's test it. The number after negative 8 is negative 9. Negative 8 is greater than equal to negative 9. That's true because negative 8 is greater than negative 9. So this is in the direction here, and it's going to go towards infinity. Okay. All right, we'll try one more, and this time I'm going to erase some of the information here so that I can have more space. And we'll do one more example. And you can go back and, you can go back and review this video on some examples, and you can see how your inequalities are graphed as well as finding the solutions. All right, I'm going to do one more. Let's do a fraction again. Solve and graph. Now n over 7 greater than, let's write that over again, n over 7. All right, n over 7, which is greater than equal to negative 1. All right, this illustrates another example when you have a fraction. So if you have a fraction, it's easy to remember to multiply. Look at the denominator and multiply that value of the denominator on both sides of the inequality, because you want to find ways to cancel fractions with the same quantity sign number. And once you do that, you have to do it on the other side. In this case, we're going to multiply by positive 7. I'll put parentheses 7. All right, 7 greater than equal to 7 negative 1. All right, and look, here's a beautiful thing. It cancels. All right, n is greater than equal to what? Negative 7. All right, and let's graph this. Put it right next to it. You have negative 7, and you have, I'll put 7, just to have both sides of the number line equating the same quantity with different signs. When is n is greater than negative 7. Again, let's graph. This is going to be a close, all right? N can't go this way because all the numbers that are in this direction are less than negative 7. So these values representing n can't go this way, but it has to go this way. When is n greater than negative 7? 0 is greater than equal to negative 7. It may not equal to exactly 7, but it is included in the series of values that are greater than negative 7. So 0 is the best fit. So you go this way and graph. One of probably the better way to identify numbers that are greater than or equal to certain inequality solutions is to use 0. 0 is a good way to test the inequality, whether it's true or false, instead of trying all these other numbers. But I mention these numbers so that you can know and recognize the direction and how these numbers behave, whether you're going from right to left. It depends upon the inequality symbol. But I appreciate your time and your patience, and this is another math session involving multiplication and division properties of inequalities where C is greater than 0, and I demonstrated that. You have a nice day, and thank you for joining me. And join me again in another session where we will continue multiplication division properties of inequalities where C is less than 0, and that's going to be very interesting. You have a great day.